All right, we're going to cover section 12.6. And things are going to start to get tricky. So, reminder, ask questions if you have them. All right, we're looking at size changes. And so we're going to start with a two-dimensional situation example. So here you have, I did this in Sketchpad, so hard to get things exact. So BA is 2.01, A prime, B prime, or B prime, A prime, 5.03. So what is the magnitude of that size change? Well, we'll take our 5.03 divided by 2.01. 2.5. We're just rounding to the nearest hundredth here. Apparently I'm writing in invisible ink. Here, I'll try this one. That one also is invisible. Third pen's the charm. All right, what is the ratio of the side lengths? So I guess that's what we just did. But that's how you find the magnitude. So then it says, what is the ratio of the perimeters? So I got this perimeter here and this perimeter here. So if we do 20.12 divided by 8.05, we get 2.499. So same, 2.5. Now, what is the ratio of the areas? So here's area. So 25.31 divided by 4.05, we get 6.249, so 6.25. So what you should be thinking is, why is the ratio of, excuse me, these 2.5, whereas this ratio is 6.25? Well, what do these have in common? These two here, they're both one-dimensional. A length is one-dimensional. The perimeter is one-dimensional. However, area is two-dimensional. And so this is 2.5, 2.5, 2.5. 6.25 is 2.5 squared. Okay? So let's go down here and look at a situation that's three-dimensional. Now, I know this might not look perfect to you. I did my best, again, in Sketchpad. So I don't know if this back piece looks bigger than this front piece, but I verified up here. So FE is 9 centimeters even, and AD is 8.99. So, or sorry, BC 8.97. So they're within hundredths of a centimeter. So that's the best I could do. Okay, so length of the large box. So here's length, and then length of the shorter box. So we see this distance is 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then the length of the small box is 1, 2, 3, 4. Then the surface area of the large box. So the length is 12. The large box is 12 by 9 by 6. And the small box is 4 by 3 by 2. Okay, so surface area, you can do perimeter times height plus 2 times the area of the base, or you can do 2LW plus 2LH plus 2 WH, whatever you want. Oops. I hope that's right. Oh, I can see it's not because I did a multiplication sign instead of a plus sign. Rotten. Let's try that. 468. That sounds better. And then for the smaller box, so 2 times 12 plus 2 times 6 plus 2 times 8. 52. The volume, so that's just 12 times 9 times 6, 648. Volume, 4 times 3 times 2 is 24. All right, so magnitude, also called the K value. So that's always the K is one-dimensional. So what is the one? You can see here the sides are in proportion, right? From the length, 4 times what is 12? It's 3. You can see 4 times 3 is 12, 3 times 3 is 9, 2 times 3 is 6. So the bigger box, in the terms of length, is 3 times as big. So that's your K value. You could also, if you're going from large box to small box, you'd say it's 3 times as big. If you're going from small to large, you would say 1/3. So the K value can be either one, depending on what the question asks for, the situation. Now notice the surface areas, are they in a ratio? Let's take a look. 468 divided by 52 is 9. And so looking back up here at the lesson we learned here, area is two-dimensional, surface area is two-dimensional. So the K squared, so the magnitude squared, K squared value is 9. That's the ratio of the areas. So then the volumes, 648 divided by 24, 27. This we call the K cubed value, the ratio of the volumes. Volume and weight are three-dimensional measurements. So notice that this obviously is 3 squared, right? My K value squared, and this is my K value cubed, right? And the same thing would work here. So you'd have, you could have your K value be 1/3 if you're going from small box to large box for your ratio, and then your K squared value would be 1/9, 1/3 squared, and then your K cubed value would be 1/27, 1/3 cubed. Okay, so this is a bit tricky to get used to. So these problems are going to challenge you, but this is your homework, and then of course reach out via email if you have questions.